In mechanics, we'll look at how objects are subject to forces on a plane or a slope, or maybe connected over a pulley, and thus create equations that allow us to say, okay, it'll move in this direction with this acceleration, and so forth. Yet another kind of model that we can have is for projectiles. That is to say, something moving through the air in an arc. Now, just as how in equilibrium we're going to have a vertical equilibrium and horizontal equilibrium, when we're working with projectiles, we're really going to be thinking separately in terms of the vertical direction and the horizontal direction. When it comes to the vertical, we're going to be basing our calculations in SUVAT, because we are going to have a constant acceleration of gravity coming downwards. As ever with these kind of models, we're going to be assuming that they're moving freely under gravity and there's no air resistance or anything, so yeah, we'll just imagine it's a constant acceleration, gravity downwards, and everything else, the variables we can find. But for the horizontal components, that is simply going to be that speed equals distance over time. Because horizontally, if we're assuming for no air resistance or anything like that, there is nothing to impact the force with which it's moving. There is no acceleration. So, all we need to do is deal with these simple three here. As such, when we look at a diagram like this, well, in this case, we're going to have a particle that's starting up here at A, and it's being projected with a speed of 32 meters per second. If you remember, speed is like the magnitude of velocity. Velocity is the specific directions. For velocity, we're going to be splitting this up here into a right-angled triangle, wherein this component here is the vertical velocity, and this component along here is the horizontal velocity. Then it's going, so this is at an angle of alpha from above the horizontal, starting 20 centimeters above the ground. It's then going to fly through the air, cross through this other point here at B, which is 16 centimeters above the ground, before finally hitting the ground at C. And then we're also told, while we don't know what the angle is, we can say that the sine of alpha is 3/5. Now, based on a diagram like this, we are then told to find the time of flight. So how long is it between the particle being projected in the first place and it hitting the ground? Then to find this horizontal distance here, OC, and then to get the speed and angle to the horizontal at B. Because again, just as how we can split up a speed here, because speed is this way, it's the resultant, but we're breaking it down into an initial horizontal and vertical. As the particle goes down here at B, we can break this up as well into another right-angled triangle. So we'll want to work out what this vertical velocity here is and what this horizontal velocity is, and we're going to want that angle there. So, how do we possibly go about working any of this? Well, to work out the time of flight, for instance, what we can say is that if we were to look in the vertical, we know what the displacement is going to be. You know that you are going to be dropping 20 centimeters. And we know that we can work out the vertical velocity. Again, whenever we're doing these separate vertical and horizontal bits, the velocity is always the component, never the overall speed. So we know the initial vertical velocity. We don't know the velocity with which it's going to hit the ground vertically, but we know that the acceleration is going to be gravity downwards, and well, we're trying to find time. Right? That gives us enough to work out the SUVAT. If we had tried to do the horizontal, while we know this initial horizontal speed, we don't know the time, and we also don't know yet what this distance OC is. We're going to be working that out next. So, yes, we're going to look in the vertical direction. We can say, okay, so your S will be the -20, your U here. So the vertical velocity here could be found by saying that, because it's a right-angled triangle, this velocity over the hypotenuse of 32 equals the sine of alpha, but we know that the sine of alpha is 3/5. So just in our rearranging, we can say therefore that this vertical velocity would be hypotenuse times the sine, would be the 32 times by the 3/5, which if you put that in a calculator, you'll find is 19.2 here. So yeah, just to specify, so you've got 32 times 3/5. And so we don't know what V is going to be, but we know that A is going to be minus 9.8, and we know that, we're trying to find T. So we have S, U, A, and T. We'll use S equals UT plus half AT squared. So the minus 20 equals the 19.2 T, and then plus half A. Well, it's going to become a minus here, and half of that will be 4.9, and that will then be T squared. Just rearranging this to bring this onto the same side, it would make the 4.9 T squared positive. Now minus 19.2 T minus 20 equals 0. This is a quadratic that you will just put into the quadratic formula. And if you do so, you will find that the time that it takes for A to go from the top here to the ground is 4.77 seconds. Technically, you also come out with minus 0.86, but that would be a negative time, and we can't have that. So again, we don't have to consider the horizontal at this same time. We just have to acknowledge that given this model in the vertical, how long would it take to get from up here at A to vertically down below it? It doesn't matter that you're moving left or right. That is until the second part of the question, when we're trying to find that distance OC. Because now that we know the time, now we can go back to this speed equals distance over time, or as we're going to rearrange it, distance equals speed times time. So the speed is going to now have to be that 32 times the cos of alpha, because the horizontal velocity is equal to the adjacent. Now, what we could do is we could do the sine inverse of 3/5 to get what alpha is, and then substitute it into cos. But there's another way of doing this. Because these questions like to throw like sine alpha equals 3/5 or some other fractions at you, and there's very specific fractions, because this is based in a 3-4-5 right-angled triangle. If we were just to throw up this triangle here, right, this angle here then is alpha. Because the sine is found by the opposite over the hypotenuse, that would put a 3 here and a 5 here. Yet because of this nature of the right-angled triangle, that would make this angle length at the bottom here 4. Therefore, we can say that the cos of the alpha equals 4/5. And if we'd wanted that tan alpha equals 3/4. This idea of a 3-4-5 triangle, as I say, is very popular on these kind of questions. So do look out for it if they do tell you what the sine of the angle is, rather than just the angle itself. Either way, as I say, this horizontal velocity would end up being the hypotenuse of 32 times by the cos alpha. So 32 times by the 4/5. That will get you 25.6. This will now times by that time of 4.77. And you are going to get a distance of approximately 122 meters. Now that we have this, move on to the next part, which is asking then for the speed and angle to the horizontal at B. Well, for the speed, because that is the resultant, that is the magnitude, we are going to need the horizontal and vertical components first to then do Pythagoras with. As I said before, there is no acceleration in the horizontal. Therefore, whatever the horizontal velocity is here, that is the horizontal velocity throughout. So we don't need to work that out again. We do now need to work out what the vertical velocity is. And that would be the equivalent of a v from our previous surat. Now in this case, our s has to change because we're no longer going down to the ground. We're just going to a point that's 16 centimeters above it. So we're going from 20 to 16. That makes our new displacement of -4. U, though, is still the 19.2, and A is still going to be the -9.8. Therefore, we would now have, S, U, V, and A. We could use T if we wanted, but A, it's a recurring decimal. And B, I always have this principle that always use the numbers that were given to you in the question, rather than the ones you worked out later in your calculation, just in case you made a mistake, right? So if we have S, U, V, and A. That's going to be like V squared equals U squared plus 2AS. So just get the V on its own. That would be the square root of your 19.2 squared plus 2 times the minus 9.8 times by the minus 4. So put that all in your calculator and you get a vertical velocity of 21.1 meters per second. Now to visualize this, therefore, to kind of zoom in on this triangle that we had for B, you are going to have a vertical downward velocity here of that 21.1, and then we're going to have one going to the right, which is still the 25.6 from 4 for that horizontal, and we're going to have a new angle here that we can label theta, and the resultant is, say, coming down this way. We can use Pythagoras to get what this resultant is, so the square root of the 21.1 squared plus the 25.6 squared, that's going to get you approximately 33.2 meters per second for your speed. And then as for the angle here, we can just use tan again, so the tan inverse of 21.1 over the 25.6, because offset over adjacent, and that will get you an angle of approximately 39.5 degrees. Okay, so if we can see in kind of this first example of a projectiles question, because we're going to have a couple of different types that we'll then go on to next, but just with this first type, if we can see how we're going to take an initial speed at an angle and split it up into vertical and horizontal components, which we can then use either SUVAT or speed distance over time for, to find different elements of this overall scenario. Let's just see how you might get along with the first example of your own. So we're told here that a vertical cliff is 73.5 meters high. Simultaneously, stone A is projected horizontally from the top with a speed of 28 meters per second, and stone B is projected from the bottom with a speed of 35 meters per second at an angle of alpha. We first of all want to prove that that cos alpha equals 4/5, and find the time when the stones collide mid-air. Okay. So again, just think back over the concept we've had. I'd suggest trying to draw out a diagram of this for yourself just to help you visualize. And either way, just have a go for yourself and then press play again on the video when you're ready to compare. So in terms of drawing this out first of all, so we have some kind of cliff and ground. We know that this cliff is 73.5 meters high. Now, your stone A is going to start at the top, and because it's starting horizontally, it's going to start off flat, but then obviously gravity is going to cause it to come downwards. Meanwhile, stone B down at the bottom, that's being projected upwards at a certain angle. It will start at that angle, but then it will start to level off and it would start coming down as well. And we can say that obviously this is going to be angle alpha here, where we've started by going at 35 meters per second for this one, and then this one going horizontally was the 28 meters per second. Now, as we can see here though, and as is indicated in the question, these stones would collide though here. So actually the right hand side of these arcs don't happen. They would something else happen. We don't need to care about that. We're just looking to get up to this moment here. Now, if we were to start trying to work out an expression for your cos alpha, we can either look again in the vertical or in the horizontal. Now what I'm going to suggest doing is starting with the horizontal in this case, because it has fewer variables. We're only looking at 3 different things here, whereas we're going to have multiple elements here, and obviously they're now going in different directions. Well, A is going down and B is going up. They're both going to the right though. They're going to have, if they're colliding, the same horizontal distance. So, if we were to look at the horizontal component of A, we're saying that that will end up being the same as the horizontal component of B. For A, again, the horizontal doesn't change. It doesn't accelerate or decelerate. So it's going to remain at a vector quantity still of 28. However, now to make it a distance, distance will be speed times time again. But we don't know what the time is, so we'll just say this 28t. As for B, its horizontal components and vertical components, we'll have to say are going to be, well, for that horizontal, 35 cos alpha. And then again, this will be times by t to go from a speed into a distance. Now, because they are colliding, the time at which they meet these horizontal distances must be the same. So we can basically just cancel out the t's because they will be the same number, there'd be a common factor. And therefore, we're just left with the cos of alpha equaling 28 over 35, which does simplify if you divide through by a factor of 7 of 4/5. Now, before we get on any further, we can now actually use this like we did in the previous question, just to give ourselves what the sign would be, just in case that comes in handy. So again, if cos alpha is 4/5, then sine alpha, for the same rationale as last time, will end up equaling 3/5. Okay. Now that we have that, we can look at then colliding in midair. Now what we can say is obviously they're going to have had different displacements at this point. They're not inherently going to meet at the midpoint of this height. Therefore, what we need to look at is if this is the vertical displacement of B going up, and then we're going to have a downward vertical displacement of A. These together must make the same as the 73.5. So, yeah, again, just to reiterate that, your S of A plus your S of B, as we've labelled them, equal 73.5. Because we now are looking in the vertical, we'll just need to probably construct our SUVATs. So, for A, what we can say is that we'll just label as S of A. The U vertically is 0, because again, it's initially projected in the horizontal. It doesn't have an original vertical component, though it developed one, obviously, because it's now going to accelerate downwards with gravity. We don't know what V is going to be, but we know that A is going to be 9.8. For this vertical component of A, because we're looking for it coming down, I'm for A taking that as the forward direction. Okay. When we come to B, I'm going to take upwards as forwards, and it's just to make sure that both of these displacements end up as positive numbers. If we insisted on doing up as forwards for both of them, or down as forwards for both of them, you'd end up with one answer being positive and one answer being negative, and then again, you just have to manually ignore the minus yourself, which you can do. It's just that you then, if you forget that, risk taking away from your total rather than combining them. So either way, yeah, because A is going down, it's going to have a positive displacement here and a positive acceleration in gravity, and then we are trying to find time. Okay. As for B, it's vertical. It's starting with for the displacement, that's just going to be your SB. For your U, that's going to be this vertical component of the initial speed. So that'll be 35 times by the sine of alpha, which we already identified is going to be 3/5. So 35 times 3/5 is going to be 21. Don't know what V is, we don't know what speed it has at that moment, but we know that A is now going to be minus 9.8, because for now, let's say for B, because it's ascending, I'll take upwards as positive. And then again, we don't know what T is going to be. But we do know that it's going to be the same T for both of them, because they're in the same spot at that same time. Therefore, what we can do is that this SA and SB can be replaced by UT plus half AT squared expressions. In regards to A's expression, the UT, well, that's not going to be anything because it's just times by 0, but then the half AT squared is going to end up being 4.9 T squared, and add to that the equivalent expression from here, so that will be 21T minus 4.9 T squared this time, and that together, let's say, will equal the 73.5. Well, a positive 4.9 T squared and a minus 4.9 T squared, they're going to cancel with each other, leaving us with just 21T equals 73.5, and so T is going to equal 3.5 seconds. That is when they will collide, that is when they have both the same vertical and horizontal distance.